The drinks are in the back now. You can grab one quietly. And that's pretty much all I have. I'm going to hand it over to Mary. Thanks very much.
Thank you. Thank you, David. Yeah, let me see. Can you hear me okay? Everybody hear me okay? Or maybe let me move it up a little higher. Yeah, I think. Hello? It's turned on, right? Can you hear me okay? Yeah, everybody. Okay, so welcome to AICAMP. And I know we normally have this, this particular one, we normally run it once a month too. So welcome everybody. It looks like we almost filled this whole room. So that's very impressive. Thank you for coming. So, okay, so today we're happy to have Cat, I think Nafiseh, that's your name, right? Yeah, and Juan, yeah, will be presenting. And Nafiseh is a scholar at University of Chicago, and Juan is a cloud architect at Bolbeck, this consulting firm. So, and then between myself and Ron, we're the co-hosts for this particular edition of the AICAMP. And then we also have Nick and Mohammed who's helping us. And we can always be welcoming any of you who want to be helping. I mean, as you can see, we're running around like chickens without heads, right? Because we have to get all the food, get everything ready. So, so yes, if you want to help, let us know too. So. Okay, so this one is something new that the AICAMP bill, he has implemented this. If you haven't already done so, please check in at the AICAMP event page and where you register. There should also be, I think, a check-in too, so to just so you can register, so he also knows who is actually here and who hasn't come. So, and that's the code. Yeah, this code is here. If you miss it, don't worry about it. We can share it with you again too later. So, okay. So first, just a couple kind of housekeeping thing. Who we are, right? AICAMP is a global AI developers community with over 300,000 AI developers in more than 150 countries. And the goal of it is to empower all the developers to learn and practice AI from anywhere at any time. So the topic areas too is very diverse too, as you can see, right? It can be LLMs, can be coding, can be doing other things in AI, right? All kinds. And there are local community chapters. So Chicago we are one of them, and in over like 50 cities and over 15 countries. And so these are just a list, example of some of the major cities where there are, AICAMP presence too. So. Okay, so again, I mentioned about how can you get involved. You can join community builders team, or if you are interested in speaking, please submit topics to speak, and that's the email address where you can send your topic proposal to. And then if you like, we are very much in need of sponsors for the meetups, especially venues and food and drink, and maybe sometimes like prices too. So today is very grateful to Microsoft for sponsoring today's meetup. Okay, and then so these are kind of how AI, AICAMP works, with our events. There are AI virtual seminar weekly, every Friday. And then there are AI meetups everywhere, monthly, usually. Well, the next one will be April 16th, tentatively. And then there are also hands-on AI workshops and boot camps and hackathons too. Okay, so this one is actually, we wanted to have a shout out too. You can you're welcome to present if you have jobs that you if you're looking for people for jobs, to do jobs, or even project collaborators or co-founders. If you're looking for jobs too, or opportunities, this is the time for you to voice, your particular needs too. So if you want to host events, you're welcome as well. So, and these are the two QR codes to join the AICAMP Slack and also the Discord server too. So if you haven't already done so. So, okay, so I'll give a few minutes to you right now if anybody wants to, advertise any job opportunities or project opportunities, or if you're looking for jobs. Yeah. So feel free to raise your hand and speak to anybody. Yeah. But if you can't think of it right now, don't worry too. I think even after this, we're going to have some social time, right? So we can still continue the conversation. So, okay. No? Nobody for today? Okay. Yeah. Don't be shy. So, okay. All right. No problem. We can, go to the next slide. And, yeah. Okay. Good? Yeah. Okay, cool. Okay, so today we want to thank Microsoft and then also Juan's company Bolbeck and also the University of Chicago for sending Cat here to speak. And now we also want to kind of advertise too, because IBM also has been kind of a good sponsor, like a consistent sponsor for our events. So there's also IBM Center for Advanced Studies, CAS Worldwide. I don't know if Ron, you want to say a word too? Yeah, okay, yeah. Did you want a microphone?
Sure.
Yeah, okay.
Or I can shout.
Yeah.
Hello. Can you guys hear me? Okay. Cool. So Center for Advanced Studies is basically our collaboration with universities, students, and research. So we do a lot of projects with them. Mostly what I'm involved with is all open source. I try to keep everything in open source world so everyone can reap the benefits of it, and we can work in a collaborative manner. But we also do some projects which are confidential, obviously, some products that are getting developed due to research and all that stuff. So if you're interested, just contact me. I'll share my info. I think you have seen my picture there. But so that's what that is. And yeah, so this is the Open Development Platform. And these are just two examples of my projects. One, I'm trying to network telescopes across the world, and I'll be going over to Adler. They're now interested, so I started with Adler and then lost contact with the Adler Planetarium. Now they're interested again, so we'll see what we can do with that project. And the next one is a project that is mainly done through NC State University at this moment. It's an autonomous racing car. Eventually, we want to turn it into a competition. So every year we open source, and then next year you have another challenge to beat the previous model and all that stuff. So it's still in its infancy, and a lot of work is being done in healthcare, manufacturing, all kinds of things. So if you're interested, just get in touch with me. And today's event is also being streamed over there at YouTube Open Development. So if someone couldn't attend, and they can watch the YouTube stream, or later on it'll be there too. So, okay, back to Mary.
All right, thank you. Thank you, Ron. So let's see. Let's see on my next one. Why is it not doing? Stuck. Sorry. I think that, oh, that's it. I think that's it, actually. That was the last slide. I didn't know. Okay, so, but with that, then I think we have this stage turned to our speakers. Who would like to go first? Kat or Juan? Yeah. Yeah. Juan will go first. Yeah, you need this, right? Oops, I'm so sorry. Not sure how you can click.
Pay no attention to the people behind the desk.
Okay. Let me turn off for now, so then it doesn't.
Can everybody hear me? All righty. Cool. This put my screen in a slightly smaller resolution, so we'll see how that goes. Perfect. All right, so welcome everybody.
Sorry, you're not sharing on Zoom?
On Zoom. I don't have the Zoom invitation. Can somebody give that to me? we get started with Zoom here. Or if you have the number, just if you can give me the meeting number, I can just type it in. Mm-hmm. Just send me an email. Okay. Give me 1 minute, ladies and gents. I see it. I don't want to do that. Copy. Will I be able to paste here? Yeah. I love magic when it works. You know, you copy from your iPhone, it comes into your, you paste it into your laptop, and everything works. It's fantastic. All right. So I should mute myself, correct? And then we are going to share my screen. Cool. Move these out of the way. And close that. Let's go. Okay. All right. Cool. Are we good? Perfect. All right. Like I was saying, welcome everybody. So today we're going to talk about building AI-powered applications using Langchain. My name is Juan Peredo. I'll be your guide in this journey. I'm an independent cloud application architect at Bolbeck LLC. I have my LinkedIn here if you want to connect. I'm happy to talk to anybody that wants to talk about AI or CI/CD or containers in general. So I'm happy to talk to you about any of those things until the sun comes down. But let's go into the topic at hand, right? So what is Langchain? Langchain is a framework that aims to make the creation of tools that are powered by AI easier and faster. And it provides you tools to do everything from application creation all the way to traceability and monitoring. So at every step of the way, they've created tools that will allow you to do this faster and easier. And we know that this is hard with AI because the moment you put an LLM into your solution, you're putting probabilities and prompts and people typing whatever they want, and you have to provide the correct information. So how does Langchain do this? Langchain has 3 main packages. There's actually 4, but we're going to talk about 3 here. The first one being LangServe, that will allow you to create a scaffolding for your application. So that will allow you to get started quickly. They'll have a ton of templates and examples that you can use in your application to get you going quickly. Then you have Langchain itself, which is the library that provides you all the tools that you need to talk to an LLM. From data manipulation, data ingestion, tracing, parsing, all of that is in Langchain. And LangSmith is the one that allows you to do all the tracing, all the monitoring that you need to do, especially when dealing with an LLM. You want to see what's coming into that LLM, what's coming out, so you can adjust your prompts, adjust your input, adjust your output. But most importantly, figuring out whether you are actually getting the answer that you want to your users. And all of this is driven by a thriving community that's provided hundreds and hundreds of examples and templates. Langchain is available as a Python package or a JavaScript library. So you can use either one of those. And I think there are implementations in Go, and I think Rust has one as well at this point. But those are not officially supported. And this is all open source. But what are chains, right? We're talking about Langchain, right? What is a chain? Well, a chain are the individual pieces that you need to interact with your LLM. And we all know that at the very high level, you need to talk about you need to use a prompt, you need to use a model, and then you provide a reply to your user. That's a very high level. But each one of those is a step of a chain. And one thing to notice is that those individual pieces may become more and more complex, but that's the basic at the end of the day of what you're trying to do. And just out of curiosity, anybody here that has never heard of Langchain? By raising hands. OK, so there's a few of us. OK, cool. So we're going to go and have a tour of the things that you can do with Langchain. And we're going to look at it in the IDE and the browser. So my screens are a little small here, so let me make this bigger. There we go. That looks better. All right. To get you started with Langchain, all you have to do is download the library, download the Langchain CLI, and all you have to do is Langchain app new. And that will create a scaffolding for you. And if we look at the code that is created, let's make this big. Can you guys see the fine print? All right, let me see. The code is too small? Yeah. Is there, yeah, maybe we can turn off the lights a little bit. If I knew how to do that. View. Window help. View. OK. Appearance. Status. Toolbars. Oh, there you go. Perfect. Thank you. All right. So at the end of the day, what it's creating when you first start or create your application is going to create an app folder. And in that app folder, it's going to create a fast API-based web service. So it basically creates a web service for you that you can use out of the box. Then it creates a package folder where you can install packages that are available for free and for you to start using. And let me move things around a little bit so I don't have to. So if I go here and I go to the Langchain Hub for the templates, there's a bunch of templates that you can start using right away to get you started. So for example, if I wanted to start using a RAG conversation, so create a RAG chain, all I needed to do is Langchain add RAG, and that would import it into my application. I could start using it. And what we're going to use today is this Pirate Speak. That basically will take whatever we type into it, and we're going to convert it to Pirate Speak. OK, and that's what I've installed here. You have a Pirate Speak package. And the last thing that it allows you out of the gate is a Docker file. So once you're done with your application, you can basically say Docker build. It will convert it to a Docker container. You can deploy it in Kubernetes, in Docker Swarm, wherever you want to deploy it. You can deploy it in Azure, AWS, wherever you want to deploy it. All right. And then for our purposes today, I've went and added a few packages, Python packages, that are going to do a few different things. So let's start looking at those. So the first one that we're going to look at is a very simple chain. And all we're going to do is what we had in the slide. We're going to have a prompt, a model, which in this case we're going to be using OpenAI, and an output parser that's going to convert the information that we got from OpenAI and output it as a text. So what does that look like? And this is the whole code, everything I've done in order to get that up and going. So I've imported chat OpenAI because I'm going to use OpenAI. If I wanted to use Anthropic, all I would do is import chat Anthropic instead, and everything else would look the same. I have a template and an output parser. So I define my model. I create a prompt, and in this case, we're going to be asking them, if I give you a fictional character, give me the movies where that fictional character has been. Then I take that prompt, I convert it into a template, and what that template is going to do is going to make it easy for our model to replace any variables that we have inside of our string. And then it's as simple as saying, I want a prompt, a model, and an output parser. And that's all I have to do. Now, if I wanted to use one of those providers of inference endpoints like Future AI, I think Firework AI, and OpenRouter, those actually are not in Langchain itself, right? We don't have, or there are no integrations for every single provider out there. But as long as those providers provide an OpenAI-looking interface, then the only thing I have to change is I have to give it, when I'm defining my model, I have to give it the model name I want to use. So in this case, I can use Mixtral 87B, and then I provide it with the URL of the endpoint where that inference point lives. So let's see all these in practice. So I'm going to go to my terminal, and I'm going to start my server. And remember, this is the server that came out of the box. I didn't do anything to this, except adding a new route. So, and it's going to come on my local. So what that's coming up, we're going to create a new entry here. It's going to take a couple of seconds. And there it goes. My server is up and running. Now, by default, it's going to redirect me to the documentation, to the OpenAPI document it's created for me. I haven't done any of this. But I have all, for example, I have my simple endpoint that I created for OpenAI. I have my OpenRouter endpoint that I created. And for each one of these things, I have the ability to invoke and interact with my LLM, either through the Swagger document or the curl, if you wanted to use curl. And I can either invoke it as a single item, I can invoke it as a batch, I can use streaming, I can look at the streaming logs or the events that are happening. All that, I didn't do anything. It just created for me. But more interesting than that is this playground that they created also for me. So if I go to OpenRouter.playground, so this is one of the chains I had created. And it's given me an interface so I can go ahead and start playing with this, right? And I can share this with people so that they can start playing with the inputs and the outputs and see if that's what they're expecting to see, right? So here, who knows a fictional character that has seen a movie? Anybody? Batman, there you go. He's been in a few movies, maybe one or two. And there we go. We have Batman, right? Just like that, we're talking to OpenAI without us having to do much. Now remember our pirate speak, right? The module that we imported. I'm going to connect to that endpoint. And you notice that this endpoint looks different, right? It's because I configured the endpoint a little slightly differently, and I'll show you that in a second. But here, let's say, hello and welcome to AICAMP. And here we go. We're talking in Parrot. It is good to to be a pirate. Right? And you notice one of the things that is added for me here is these additional buttons, right? So I can say, oh, this is a good answer. This one is OK. And it's automatically recording that for me. Okay? And where is it recording it? Well, it's recording it to LangSmith. And what does that look like? Well, let's go take a look at the trace. And once I allow pop-ups, it pops up, and it gives me all the information about what happened in that particular call. So that I can actually debug when something goes wrong, and I can see the different parts of the chain. So this is a very simple chain. All it is just calling OpenAI, and we can see the input. So translate input into pirate speak, what I told it, and what was the result. I've done all that without having to spend almost any time. And then I can even open that on the playground. And let's say you have another person that's going to be adjusting the LLM. I can come in here. I can say, oh, instead of pirate, I can say, okay, I want to do this in Klingon. I could hit test. King long. Oh. See, I know Langchain. Now, typing in English is hard. All right. But bottom line is you can come in here and play with different models. You can play with different temperatures to try to figure out what the best settings for your LLM is so you can get the best answers. But there's, so that's a simple prompt. So let's take a look at something a little more complicated. So instead of doing that, let's go ahead. Let's build a RAG chain. And for those that are not familiar with RAG, you basically want to talk to your documents. So this is a way for you to use AI for your own documents, right? And this has been in the news. It's very popular. Everybody wants to build it. It's really hard to build once you get it right. But to actually build the code is pretty straightforward. So you basically, there's two parts to the process. So the first part, you take up all your documents that you want to talk to. You embed them, so you create numerical representations of those documents. And you store it in a vector database. In this case, I'm using Qdrant. There's Chroma, there's PG Vectors, a bunch of databases that you can use. Once you have your documents there, then you can take questions from your users. And at that point, you take that question, you take it to the same process of embedding, creating the embeddings. So you're converting once again into a numerical representation. And then you do a similarity search in the database. Give me all the documents that have strings that are similar to what I have here. That gives me a set of documents that are hopefully going to answer my question. And I say hopefully because it's not always right. And then I take that user question in those documents, I put it in the prompt, and then you just call the LLM as normal. So let's see what it takes to do something like this. I'm not going to go into the details of all the code, but first of all, I have to import those documents. So this is the first part what we saw. I import those documents. So I just do the Langchain text loader. Then I split those documents into little chunks so that we can search for those little chunks of well, they're not sentences, but they're pieces of sentences. Then I can search through those to find things that are similar to that particular question. And then once I have my little pieces and my little chunks of documents, then I load it into the database. And in this case, as I said, I'm using Qdrant. If I wanted to use a different vector store, I could just come in here, and instead of importing Qdrant from the vector store, I could import, let's say, Chroma. And then I could start using ChromaDB, and the rest of the code would look basically the same thing. And then at the end, I create a retriever. So a retriever, the whole point of this retriever is to say, I'm going to receive a piece of information, and I'm going to look in the database for something that matches that. And then I'm going to go and I'm going to build my chain. And my chain looks pretty much almost exactly the way we had it, right? So we have a prompt, we have a model, we have a parser. But what's our prompt? I didn't have a prompt here. I didn't have any text. Well, the prompt actually this time, I'm pulling it from the Langchain hub. And the Langchain hub is where you can put shared prompts with the world. So in this case, I'm using this prompt from the prompt hub. And you can have these public prompts, private prompts, things that you share only with your organization. And we can see that in this particular prompt, we have a space for a question and for some context. And in that context, we're going to put all the documents that we want to search from, right? So we'll have the question and the context in there. And that's what this is going to be doing here. We're going to have a piece of code that's going to run the retriever based on the question that we're passing. And as a result of that, it's going to put in the context variable and the question variable that we had in our prompt once this is passed to our prompt. So if anybody is familiar with the Unix syntax, this is basically a pipe, and basically means that whatever resulted from here, use it here, and use it here, and use it here, and so it's passed down the chain. And that's all I need to do to have a proper RAG chain. Now, when I say proper, this is a very naive Langchain. This is a simple RAG chain that you can make. But let's see how it works. So I'm going to go back to our playground, and I am going to change this to RAG. And the document that we're going to be searching through today is a document I had created a long time ago, well, 4 years ago, for a conference that I was giving in Wisconsin in 24 years ago. Time flies. Time flies when you're having fun, people. All right. So we're going to ask a question to that LLM. I'm going to say, what year was the conference? So go through, and it gives me the answer. And indeed, it's 2020. But more important is what's happening behind the scenes. Right? So we ran our retriever. The retriever came up with 4 pieces of the document that had information about when the conference was taking place. That information was sent to our OpenAI model, and it contained the question and all the document that we had pulled, as well as what document is pulling from. So I know exactly what document I am using, and I can actually display it to my user. This is where you got that information. That's RAG. Now, if we move on to the next one. So next one, let's see how we can have our models interact with the world. All right? And for that, we're going to create agents. And agents are just a collection of tools that we're going to allow our LLM to interact with. So in here, it's a very simple. We're going to have our model interact with a multiply function, an add function, and an exponential function. Right? But this could do anything, right? We could ask it to run something in the real world, or we can ask it to do pretty much anything, right? So in this case, first the model is going to run, decide what it needs to do, and then it's going to calculate the final answer and return it to us. So let's see how that's done. That is very similar to what we did before. The first thing that we're going to do, we're going to define the multiply, add, and exponential functions. And then we're going to decorate it with the tool decorator. And that allows OpenAI to know that it can use those tools. Then we're defining our prompt. Once again, I'm pulling it from the hub. I have a little list that has all my tools that I'm going to use, and then I create my agent. Right? And in this time is an OpenAI agent that I'm going to be using. And finally, I declare an agent executor. And an agent executor is just what's going to run this agent. Right? This is going to call the LLM, it's going to call the functions, and it's going to give us our result. And then I'm telling it explicitly this time that I'm expecting the result of the input to this executor to be a string. And finally, I process that the output of the LLM and display the output portion. So let's take a look at that. And this is agent. Agent. All right. So now, because I explicitly told it that I needed a mandatory input, that's going to be a string. Now give me an error until I populate it. And now we're telling it to take 3 to the 5th power, multiply the sum by 12 and 3, and then square the whole result. I don't know about you all, but that hurts my head when I try to do that in my head. So this shows me what is done and the final result. But once again, more interesting is what's happening under the hood. Under the hood, we can see that OpenAI was first called, and its first result was that I needed to exponentiate something. Wow, that's a hard word to say, exponentiate. All right, so we realized that it has 3 tools. Then first it's done something to the exponent, then it's added some numbers, then it's multiplied some numbers, and eventually gets back to the answer. Now we see every single step, everything that's been taking place. So if something goes wrong, it's really easy to figure out what's happening under the hood. Now, we can also have the ability to have a fallback. So let's say you're running your model, and all of a sudden your connection to OpenAI decides and dies. The last thing you want to do is tell your users, oh, well, sorry. So you can have a fallback, right? So you can run a second model instead. And that is very straightforward to do. So in our case, we're going to have 2 models, GPT 3.5 and GPT fake. GPT fake, all the rage, #1, Hugging Face. No, just kidding. This is totally going to fail. And we're going to create 2 chains. The first chain is going to be the bad chain using the bad model. We're going to create a second chain, and then we're going to have a fallback. So we're going to run the chain with a fallback. Right? So let's try that. Oops, wrong place. All right, here we're asking, the question to the LLM is, why did the animal cross the road, right? So it has to be a chicken, come on, that's the joke, right? All right, so we wait a second. Yes, classic riddle. I appreciate it. All right, so look at the multi-chain. If we look under the hood, we can see that it's actually failed the first time we tried to call OpenAI. But us as users, we have no idea that that's happened. All right, let's take a look at one more for luck. And the next one we're going to look at is the one I have highlighted. Let's say that you have models that you've trained on certain subjects. Like, for example, one could be for medicine, the other one for physics, or in our case, one for Star Wars, one for Star Trek, and one for as a general chain. We're going to use a router chain or a classification chain that's going to tell us which model to go to. Right? And it's going to hit one of those three. And then it's going to return the answer from one of those three packages. And if we go there, we have two different models. And then we're going to come in here, and we're going to create four chains. The first chain is our classification chain. That basically says, we're going to ask you a question, and you're going to tell us if this is Star Trek, Star Wars, or this is something else. All right? Then depending on that, you're going to run one of our other three chains that we've created. And then we create our final chain. And so at the end of the day, it's going to run our classification chain. That's going to give us a topic and a question. And we'll pass it to our routing. And our route is nothing but if the topic is Star Trek, run the Star Trek chain. If it's Star Wars, run Star Wars. Otherwise, just send it to the general chain. And that's pretty straightforward. So let's run that. All right, let's see. Who is Han Solo? And apparently he's a scoundrel. And once again, if we look at the chain, you can see that the result of the first call to the LLM was Star Wars, and then he called our Star Wars chain. That's all nice and good. So we can see how we can trace our results, but we can do also other things here. We can do monitoring of our chains over time. So you can see over time the number of trace counts, the number of LLM counts, latency, something going on, what's going on over there. We can see number of tokens we've sent. All that information is readily available to us. And the only thing I need to do to enable LangSmith in my project is set up these 4 environment variables. And all that starts to be captured in LangSmith. That's all I had to do. Didn't have to do any wiring, anything like that. There's an SDK if you want to have more control, but that's really the easiest way, and you already see how much information we get on our traces. We have input, output. We even have cost. How much did it cost me to run each one of those things? So at the end of the day, I can go and do some math to figure out how much it cost me to do this demo. All right. Another thing that is interesting that we can do here is we can use what's called data sets and annotations. Right? So annotations are a way to have a human in the loop. Right? So I'm going to come in here and I'm going to say, I want to send this to an annotation queue. It's going to ask me which annotation queue you want to send it to. And once it's sent to the annotation queue, I can go to my queue, and I can, for example, assign this to somebody to go and look at all these replies that I've gotten from my LLM. And I can say, this is a good or a bad chain. It's relevant, irrelevant, and I can add additional tags there. I can put a comment. And then when I'm done, I can just click done. And then this becomes available as part of the data for this chain, right? that you can use to evaluate your chain further down the line. Other thing that we can do is create a data set of those runs that I've done, right? So I can go to my runs, and just like I said, add to annotation, I can also say add to data set. And here I created a sample data set that had, anytime anybody asks about a command, this is the information I'm expecting to see. Now, it may not exactly look like that because LLMs will give you different answers, but they will have the same semantic meaning, or they have to have. And then I can just run those. And I can see, for example, over time, this is my latency, but I can have multiple items in there. And for each one of those runs, it shows me, this is my reference input. This is my reference output. And then it gives me grading for each one of those runs. And it also gives me an explanation of why it thinks that the answer was correct, incorrect, et cetera, et cetera. So that's pretty cool. Now, the next question obviously becomes, how are you setting up what you're testing for, right? So I can create a new test run, right? And I can say, I want to test this for relevance, correctness, helpfulness, and sensitivity, for example. And at this point, it created all the code I need on this side of the screen. And all I have to do is take that code, I pull it into Langchain. So I want to create a new, or I'm going to use it in an evaluation. And in the evaluation, all I have is the definition of my chain that I want to evaluate, which in this case is our fictional character again. And then I copy-paste the code that it gave me. All right? And these are the evaluators that it's going to run. In this case, relevance and insensitivity. And I can create my own evaluation. And then I can just run this. So it's going to run 5 runs. I can have as many as I need to. And all I have to do to have that run is take a look. Just run my evaluator, and the evaluator is going to start going through every single one of those runs. So it's going to go 0 through 5, et cetera, et cetera. And at the end of the day, it's going to look like any other these other runs that have happened. All right, I feel like I've thrown a lot of information your way. Any questions? Yes. Yeah. For the routing, land graph. Yeah. I think we're going to give it a mic. OK.
Question was
for the Langchain routing, how is that different from LangGraph?
That's a good question. All right. And this cooperated with me. So it's not different. So LangGraph is for bigger and stateful chains, right? It's something that you're going to, oops, sorry. It's something that you want to do when you have, like 10, 20 steps, right? And where you may potentially have stateful situations. What we did here is for something a lot simpler.
Right. OK.
Yeah. It's the same concept, though. You're basically going through step.
Right. And as part of that, coding all those steps, how is that different from just coding yourself? I know one example that people use is internet browsing, where if you're trying to research a topic, having it go through that chain process is much more efficient than trying to code it out. Is that the main use case, or is there another use case that you could think of?
For internet browser, there is several integrations. So with DuckDuckGo, Tably, where you can just import that and use it as a tool, just like the agents that we used.
Gotcha. Okay.
So it makes it a lot easier. Other questions?
Thanks. That was a great talk. Have you used the agents functionality a lot, in Langchain, and what has been your experience with it? I've heard kind of conflicting things about how valuable people have found it. Have you gotten a lot of good use out of it?
I think there's been a lot of changes in the last 2 months or 3 months. I think actually since the beginning of the year, on the way you're using the tools. Before it was a straight use of OpenAI functions, and that was kind of iffy because it was just a string manipulation that they were doing on the covers. The new agent functionality is a lot more robust. There's still times where you have to get your hands dirty, but I noticed that it's much better now.
Thanks.
I have a question regarding the tools feature of Langchain. So we saw the simple example with multiply, divide, and add subtraction. So what does the tool exactly do? Does the LLM actually respond back to the server which we are hosting, or does the LLM take the logic from our code and then apply it there?
It does not apply it there. It will actually send back the function that you need to call and the parameters, so the variables that you need to use in that function. Now, the agent executor wraps that around and actually calls the code for you.
Yeah.
But the LLM is just replying text.
Yeah, so we don't need to specify any particular API key or something, or should it be public, those particular endpoints?
Well, it depends on how you're doing your application, right? It doesn't, if you're building it yourself, right? And you can either call, OpenAI, which if you're in a company I don't recommend, right? For obvious reasons. Or you can call your own LLM, right? That you're hosting on site.
Yeah.
But that doesn't matter, that depends on you.
Okay.
Right next to you.
First of all, thank you for the session. It was very insightful. And I saw that there was a logic where the prompt was used, a document was used to read, and based on the prompt given, it was giving back the solution, right? One interesting thing was it was MD file, markdown document. Is there any specific reason why it was used, or normal PDF? If we have the stack of PDF files, will the same logic work on PDF files?
Yes and no. So it will work with PDFs. Now, when it gets to trying to understand tables and graphics, then it gets a little iffy. Right? Now, there's new technologies that are coming out to make LLMs understand the tables and the illustrations. In fact, I think Llama Index just announced one that they claim the whole thing without any problems, but I haven't tried it. But a normal PDF without tables and text and illustration, it will handle no problem. But for complex documents, you may have to use specialized tools.
Okay, thank you. Thank you so much.
Other questions? That one over here. Oh.
Hello. Hey, Juan, it was a really nice presentation. How can we hide the sensitive data in the document? For example, if I'm asking if I have a document which has sensitive information like SSN or date of birth, and I want to hide it. What encryption mechanisms can we use in this?
The best encryption mechanism is don't put it in your database. That's the best. But if you have to, right, there are ways to have the LLM identify PII, right, and extract it. So when you're embedding, it will actually extract that piece of data and not put it in. Mm-hmm. So that's the best way to do it.
Okay, thank you.
Bouncing off that previous question, especially concerning sensitive information, one of my interests has been LLMs and say mental health resources or medical resources, or even educational resources that contain sensitive information. What would you say is, if we want to build an internal LLM, or if we want to build an internal tool using Langchain, mm-hmm. What's the, well, okay, first of all, where would we even start with in terms of like security or making a very secure Langchain tool? How we guarantee the security?
Well,
besides not putting it in the first place.
Yeah, well, yeah. So this is, at the end of the day, it's a normal application, right? First of all, you have to put it behind, I would say, put it behind a load balancer. Make sure that or an API gateway. Make sure that you're controlling that with Cognito or whatever other authentication provider that you're using. Make sure that you don't have incorrect access to the database. So the regular rules that you use for a regular application still apply. That hasn't changed, right? The other thing I was saying, which is one of those questions that was asked, is make sure that you don't call to an outside source to get your inference, right? So make sure that your model that you're creating, you run it on your own hardware, or in your own cloud. So basically, if you have your own VPC, whether it's in AWS or IBM or Azure, make sure that that is secured. Mm-hmm. You're welcome.
One more question about LangSmith. When you have, can you create a cache of most commonly used answers using the annotator? Would that be held on the LangSmith side, or would you put that on the index or a database side for commonly retrieved documents?
The way I would do that is actually, and I saw a client doing this with Redis. They actually put your prompt, your Redis cache, and then your LLM, right? So it would hit, the prompt would actually first do a relevant similarity search on the cache that was looking in Redis. And then if you didn't find anything in the cache, then it would hit the database, the actual database. Now the trick there is, there are 10 ways of asking for the same information, right? Mm-hmm. So the cache ratio may be off, right? So you have to put enough information on that cache so that you can actually have enough hits there. Otherwise, it's a waste.
Gotcha. So it sounds like it's very much a mixture of the index side. Okay, thank you.
The other problem is it might not be the most relevant in the cache for that particular combination of the question.
Correct. Yeah. Then it's a cache miss, and you go to the database. Yeah.
Hello?
Yep. Hey.
I'd like to say thank you for your talk. I love your accent.
Thank you. I've been working on it for like 40 years or so.
It's very whimsical. Are you a Star Wars or Star Trek?
Star Trek.
Star Trek?
Sorry, man. For those Star Wars fans, sorry, I'm Star Trek.
I'm more Dune. That's all.
All right. I like those hard questions. Any other questions? No, that's it. All right. Well, it's been great. Thanks to AICAMP for organizing these meetups and Microsoft for hosting us today. I really appreciate it. And if you have any questions, please feel free to talk to me after the talks. The code? Mm-hmm. It's in GitHub. Yeah, it's in GitHub.
Is it can it be shared?
Yeah, I'll put it on the. Oh, nobody's in the chat. Yes, let me put that up real quick.
Yeah, just send it to Mary and then we can.
Okay, I'll send it to Mary. Yeah.
So just before you go, everybody thank Juan for the food, since his company is sponsoring.
You're welcome.
Now we'll have Nafiseh right here.
You need power? Oh, you need the mic.
Hello, everybody. I'm Cati Mollaei, and it's a pleasure to have you here. It doesn't work. Okay. So I graduated PhD in biomedical engineering with partnership of Volkswagen, and I finished my education in Portugal. Then I moved to the United States for continuing my education in postdoctoral, actually. So first I start with Loyola University Chicago in data science and health informatics, and then I go to University of Chicago to actually research in biomedical data science, and basically my main major is how we can use large language models in healthcare. So I have around 10 years experience in health data sets by using AI algorithms. So first of all, I'm going to talk about why we're using large language models and how we can use this powerful AI technology to generate huge text. And then I will explain about how we use clinical notes by using large language models in the huge text. And after that, I'm going to talk about the medical error and how we use these medical error in the part of our clinical notes. So basically, as you see, the trend of large language models is from 2018. So it started with BERT, and then after a while till now, we have different kind of large language models, which basically the recent one is Llama and MedPalm. So we use these kind of large language models basically in the different kind of clinical notes and progress notes. So the first question is that why large language models and how it's applicable in the medicine. So first of all, I want to let you know that medical doctors spend on average 50 to 100 minutes in writing clinical notes, so they can use the generation of these clinical notes with the less time. And the time that these medical doctors spend in electronic health record systems contribute to high rates of attrition, and with the burnout rate already existing 15%. So recent studies on clinical notes generation shows that doctors can save a significant amount of time with automatic notes generation. So basically, these progression in large language models can play a key role in medicine, and also it needs huge benchmarks and data sets for assisting which models would best serve clinicians in their daily practice. So I can say another part of this advantage of large language model is the documentation and clinical notes can help physicians and clinicians in finding medical errors. So they can use these large language models for medical error treatment and medication. So the second part that I would like to talk about is clinical notes from doctor-patient conversations. So basically, a recent progress in large language models opens the door to clinical application and improve efficiency of clinical practice. So first of all, it can extract information from the large clinical notes, and even in these kind of generation, clinical notes can help physicians for having the lecture review and up-to-date information and even trustworthy information. And the second one I wanted to mention about that is recommendation and predictions. So they can use large language model in predictions, diseases, and also identifying high-risk patients. And even they can use these large language models for recommending personalized treatment, intervention, and clinical trials. And the second point that is really interesting in recent decades is the generating clinical notes. So these clinical notes can decrease the doctor documentation time, and even it can automate the administrative tasks such as medical errors, and even it can usable in the different kind of diagnosis accuracy. So in this part, I wanted to explain more about why these large language model in medicine is so important. So first of all, I'm going to talk about why these large language-based solutions are important in the clinical notes, and then I will explain about how we can actually use this large language model for medication, treatment, and even how we can correct the medical errors in clinical notes. So in our study, basically, we have the inertia problem. So we have the inertia disease that mostly doctors doesn't know how they can correctly treatment these disease. And then this disease also is reported to physicians to understand if they can use another kind of the methods to cure that inertia. So actually, we are working on these methods to use the large language models to identify which kind of the factors are related with these treatment of inertia. So basically, by using the relations between the treatment inertia and the factors, we can understand if, for example, these patients has the inertia or not. So what are the problems that doctors doesn't understand and doesn't know how they can cure the patients? So basically, uncertainty regarding clinical blood pressure measurement and orthostatic symptoms also present, and even home blood pressure measurement are at goal. And sometimes patients report medication non-adherence or refusal to initiate blood pressure medication. And in this case, mainly 60% of time doctors couldn't understand why the blood pressure is high and how they can understand that which kind of the factors can be, for example, applicable for the treatment of inertia. So these examples simply can be, for example, patients doesn't like to report their medication. Sometimes they use the fast food. Sometimes they don't like to use the medication. Or sometimes they have a full stress. So these kind of factors doesn't actually works for the treatment of inertia. And sometimes from the physicians, they couldn't have a good relations with the patients, and even sometimes they doesn't pursue or follow up the medications when the blood pressure is uncontrolled. So, and the last one maybe happened that doctors and patient doesn't like each other. So in this case, maybe they don't want to report to each other. So in our study, we have the database, progress notes around 10 years. So we collected these notes from 2014 till now. So we have 3,412 visits. So these are related to 6,757 patients. And the number of for example, one patient who visited the doctors maybe can be 35 times, or maybe the patients just once go to the doctor. So these kind of the evaluation give us the insight to know how we can actually provide the clinical notes and even the word counts together. So as you see, for example, we can see that if we have more documents and even we have more repetitive words in those documents. So in this case, generating clinical topics from doctor-patient conversations can contribute to reducing the doctor's workload by validating these clinical notes, and instead they can use generation these clinical notes instead of using the writing the normal consultation. And even the lack of publicity of these database is another reason that we understand we have to work in this project, and we can create our own database to pursue treatment of inertia. So why we use large language model in inertia? So by using this AI technology, we can detect inertia by extracting and analyzing clinical information from progress notes. So by using these large language models, we can detect inertia in hypertension management and process progress note to extract main keywords in medicine. And even another reason is that the clinical information used to input the pre-trained large language model, and we can then use this model to identify which kind of the medication is better for the patients. So first of all, before I go to the large language models, I wanted to explain a little about the topic modeling. So topic modeling is useful for analyzing unstructured clinical notes. So by using topic modeling, we can find hidden patterns between information and effect explorations between the information of the patient. For example, how many times the patient comes and which kind of the medication on treatment happens. So we can track all the patients that are similar together about their medication. And even we can cohort identification by using the tracking of these progressions. So we can use the cohort identification to monitor patients and track their progression. And then we use this model for the clinical decision support. So they can use it in their own model to understand if their medications are correct or not. So per topic is one of the topic modeling that I used in this project. So BERT topic is one of the methods that we can extract, summarize, and generate clinical notes. So by using these methods, we can annotate and extract the main topic by predicting models in the treatment of inertia. So the architecture of the BERT topic is like that. So we have the traditional LDA, which is the traditional topic modeling, and we have the BERT, which is use the sentence embedding, and we combining these two together. Then we can understand which kind of the cluster we have. So we clusters the topic based on the information and the terms that they have. So the diagrams of this study is, first of all, we have the notes, so we get together all the notes together, and then we use the topic modeling for evaluating these texts, and then we predict which kind of the topics we have. In basically, we have topic 1 to topic M, so we can choose how many topics we need. And then by using the classification methods, we give our input model as a notes. So clinical notes would be the input data for our model, and it shows that in output how these topics are relevant with the different kind of our main topic, I mean our clusters. And after that, by using it, we can predict the inertia. So if these patients, based on these factors, has inertia or not. So these kind of large language models can be used for medical error, and we can use these large language model even for correct the medical errors. So basically, first of all, I wanted to show you the traditional output of our model. So it shows that we can, for example, I can show you the dynamic one. So here is the dynamic LDA. So we can use, for example, 10 main clusters. So by choosing one of the topics, we can understand, for example, among 30 topics, how much each of the, for example, these keywords are relevant to that topics. So it is the traditional models of our study, but in the BERT topic, we have the different kind of the actually evaluation. So we choose, for example, 10 main topics, and these 10 main topics, we can also regulate the amount of keywords that we can extract from clinical notes. So basically, by extracting keywords in clinical notes, the physicians can understand, for example, which topics can be usable for each cluster. So this evaluation then delivered to the physicians. So physicians can give us the name of each topic for each clusters. So basically, for example, here you can guess that these keywords are related to cancer. So basically, doctors can give the topic 3 cancer as a main name of this cluster. So we have another kind of evaluation for BERT topic. This is shows as a clustering, but I can show you the main. So here is our clustering by BERT topic. So it was really interesting for physicians who evaluate their their prescriptions by these kind of extractions keyword. So for the BERT topic, we have around 400 topics that has around 50 clusters. So these 50 clusters, if we put like this mouse in each of the cluster, it shows which kind of the keywords are related to which kind of the cluster. So in this case, they can understand the main relations between each cluster to each other, and even which kind of the actually disease impact in the another disease. So in this case, they can enhance their efficiency of their medication. So it already delivered to physicians and clinicians to evaluate this kind of the evaluation. So how we can use this kind of large language model accuracy? So basically we have the UMass matrix. By using this UMass, we understand that if these topics are very close together and how we use this kind of the trend in our evaluation matrix. So if it's minus is really great, and if it has a near close together is better, and we can understand that how these overall topics coherence of our topic model. So by using this kind of large language models in healthcare, we can understand that medical errors can be costly for even patients and healthcare providers. And detection and correction of these errors is important for improving healthcare outcomes. So by using these large language models, we can able faster and more accurate solution for detecting medical errors. So these medical errors can be misdiagnosis or medication errors. So misdiagnosis means that we can use these large language models to identify inconsistency between the patient's symptoms and even diagnosis which is written in the clinical notes. Or even we can understand that medical errors about the duration of medication or frequency times that the patients use the medication, or even they can actually use this large language model for using the these medications for the particular patients, for example, who has two diseases at the same time. So these large language models can assist the physicians by suggesting corrections and recommending different kind of personal treatment and even interventions. So what is the challenges of this large language model? Is there any disadvantage of using this kind of the AI technology? Yes, there is such kind of challenges by using large language models in medicine. So it can have a bias, or it can have some problems in the treatment. For example, it's used for some medication, but it shows that medications doesn't well enough for that kind of the disease, or has some privacy concern that physicians doesn't like to use this kind of AI models. And even using this kind of the large language models can, for example, solve these problems regularly, and then physicians can use this kind of the large language models in the future aspects. So they can use the large language model based solution in their medical errors and can count on our models for future medications. Thank you. Is there any question?
Hello. Oh, that was an excellent talk. Thank you so much. Quick question: are you publishing any of this in any publications in the near future, or do you have any references for this work?
It's recent study, so birth topic is really new LLMs. So it is kind of the multidisciplinary group. So we are there, for example, bioinformatic person, we have engineering, and we have physicians. So three of us should have one idea for this research, but we drafted our study and we are going to publish soon. Any other question?
Thank you. My question is, what is the accuracy of the test LLM thus far? Percentage of accuracy according to like the medical staff?
There is different kind of evaluations that we can have. For example, perplexity or UMass, as I showed you in this slide. I can take the slide. So it shows that how this model works is here. This model. So if the trend is minus, so the model works correct. And it shows that how these topics are relevant to each other. So basically, by using the birth topic, we can cluster the similar topics. And by these clusters, we can guess that which kind of these keywords are related to, for example, disease. So the part of the, for example, predicting the keywords related to that disease, it's the physician's responsibility. But using the accuracy for our model is like UMass matrix. So this kind of the matrix is for evaluating our model.
I know with the bird topic, you talked about embedding. Could it be potentially used to match up other patients? Suppose you had one patient who has this kind of medical notes with this kind of history. Could it be potentially matched up with another patient, saying to predict new diseases? Like maybe this patient has similar starts of a disease to another patient who ended with this result. Because I have family who work in the medical industry, and they talk about how just being able to see research of what other patient histories of what they were treated for gives ideas to new treatments. It might have been answered, but just want to ask that again.
Exactly. It is one of the main approach for using birth topics. So the physicians who create these clinical notes, actually they knows about each disease. So they know, for example, if the person who has diabetes, or maybe has a high blood pressure, or elderly persons, has the high blood pressure or diabetes. So they know these kind of the relations between different kind of the diseases. That's why one of the reasons that we could use some kind of the methods to guess which kind of the name for each cluster has, but we give it to physicians that because of this reason. So they know these keywords are related to this disease, and that reasons they choose one topic for all the clusters,
I see. So it's using their expert opinions almost to influence and classify it even better, because it's hard to get that knowledge from their brain. Thank you.
Exactly.
Can you hear me? Yes. All right, thank you. On a more niche topic, I did want to ask about LLMs and being used in psychotherapy, behavioral therapy, cognitive therapy. Has there been any research regarding LLMs and, say, clinical psychology in your experience? I understand cognitive and behavioral therapy might be a little different, but perhaps this is something that could cut down the time a patient would need to progress through either cognitive therapy to get a diagnosis, for example.
That's a good question. It is one of our suggestions for Attendees research. So we can add different kind of the factors. So it can, from psychology factors, it can, maybe this person has a depression, so it has always a stress, you know. So this stress can affect on their medication, you know. So we are going to add other kind of the factors, such as psychology, such as we wanted to know if these patients are, for example, related to which area. For example, like Chicago, if it's the suburb or if it's in the downtown. So maybe their education effect on their medication and everything, like you said. So we can add the different factors to our model to predict better, like this kind of the outputs.
How much research has been done in verifying the accuracy of the comorbidities in the LLMs that you've presented to us, especially in behavioral psychology and cognitive therapy? Many disorders do have comorbidities, such as ADHD also has a comorbidity of maladaptive daydreaming, for example.
Well, it depends on the physician decision. So they make a decision that which kind of the, for example, clinical notes that can be used in LLM or even in other kind of AI algorithms, you know. And we have another kind of AI algorithm which is named explainable AI. Explainable AI is one of the another AI algorithms that it exactly shows which kind of the factors with which percentage effect on our output model. So this kind of the approach can help the physician and even our models to give us a better accuracy for our input modes.
Follow on to that. So, hello. Yeah, so we were doing a sort of a research which I suspended one of my researchers. And for the psychological aspect, we were actually looking into neurotransmitters. So I understand what you're actually doing is trying to look into and research into the notes that the doctors are putting in and clustering information and then characterizing what other suggestions to give back to the doctor, right? So that's the process, right?
Exactly.
So we were trying to see if there's neurotransmitters that we can predict, right? So there's, we can talk about that later on offline, but we called it Nectar. So there's neurotransmitters that can be actually indirectly monitored, right? So say dopamine levels inside the brain, you cannot actually measure that unless you put a probe inside your brain. So that's not an option with human beings. You can do it with lab mice and stuff. We've done some experiments. But there's indirect ways of doing that, like the involuntary blinking of the eye is related to dopamine levels. So anyway, so that's something that we were looking at, and more than happy to discuss offline. Yeah.
Maybe future collaboration.
Oh, sure. I'm always open to collaborations, and if there's interest, we can look into it. Yeah.
A pleasure.
Yeah.
I have a question regarding the processing of the data while building the LLM. So I've seen a lot of doctor notes while growing up. How did you account for the typos and all while clustering the data?
Well, we use the NLTK library, so different kind of pre-processing, parsing, and even word embedding. We use many kind of pre-processing that I didn't mention about it because it was the first step of input model. So where first we clear all the stop words. We use them around 7 methods of pre-processing to first organize our data sets, and then we use the large language models for our models.
And does the pre-processing also like include the various medicine names and all which might not be in the like libraries or something?
Yes, sometimes it is the same because, for example, if we have the synonym for the medication, we choose just one, you know. So we eliminate the others because there are, for example, if we have BP or we have blood pressure, so we just keep the BP and we deleted the, for example, blood pressure, and we keep the same, for example, keyword for all the clinical notes.
Okay, thank you.
Yeah, on the same note, like as you told, there might be two medication with similar sounds, like with synonyms or something. Actually, we were working on the similar project where taking the notes based on the conversation of the patient and doctor, recording that audio and converting into a document and using LLM to make a notes on that. The problem that we were facing was when there was a medication which was prescribed with the similar syllables or something, the notes was going to the other way, which was a bigger problem. Like doctor has prescribed something and the notes has generated something. These kind of issues, is there a way like, I think this is one of the major issues that we faced. Like any suggestions that you?
Yes, in this case, actually, we use the consultation with the physicians. So sometimes I had a problem, like as you said, the medications name. So we had many meetings with the clinicians to talk about if we use this one or that one. And in this case, even we create an NER model, new NER model, to extract just nouns from all the clinical notes, and then we evaluate them. Each kind of these medications are similar to each other, and we deliver to physician, and the physicians take it back to us, you know. So I think in your case, we can use NER models to like extract all your noun names, and then you can, for example, consult with some physicians or something like that.
Thank you.
Hi. Thank you for the presentation. It's a very interesting use case. So I have two questions. First is about the detection of medical errors. So do you, exactly, yeah, this page. So do you use LLM to generate the, how can I say, to generate the notes and compare the big language model generated notes to the real notes written by the doctor? Is that the way you, detection of the medical error, or you also need some real medical error notes as the input to train your detection model? Because if you also use real medical errors, medical errors may be very rare cases. You might not have enough data to train your detection model. So I just want to confirm which way you use for the detection.
Actually, the second one, basically, we do these kind of studies to understand if we can find any relations between the factors that can find with the treatment of inertia. So we use this kind of approach to understand if the patient has inertia or not, you know. So the medical error that I mentioned is that the physician sometimes basically based on these predictions guess that this patient has a inertia. But with our approach, they understand that no, for example, this patient doesn't have this inertia.
Okay. The second question, can you go back to page 19, I guess? The next page, please. Oh, okay, this one. So you mentioned you built your own database. So I wonder, how how you work, how you use the LLM models with your self-built database. Do you use the LLM to create your database, or you use the database for as the domain knowledge resource for LLM to generate some nodes? Which way is your mainstream? And I mean, what kind of database do you use? Like, because those are nodes, are documents. So do you use like a vector database or just some traditional RDBMS? Because you already embedded those documents. So which technology you are using? Thanks.
So we use raw clinical notes. So basically, any patient go to the doctor and they write the clinical notes, then these kind of prescriptions transfer to us. So it's completely raw clinical notes. And one of the reasons that I use the birth topic is this kind of approach can summarize the clinical notes. So they created topics, you know. So these kind of the topics can be 2 syllable, can be 3 syllable, you know. So as I showed you in the here, so you see each kind of the cluster can be 3 or can be 4. You see it's 5, and here is a 5, you know. So these kind of topics extracted from the informations. And after that, model can analyze these topics to understand if these kind of topics are related to that notes or not. So as I showed you, the diagram, first we have a clinical note and then we give it to the model, and this model extract the main topics, but we can choose how many topics we need. And after that, we give this topic to our nodes, to our raw nodes. So basically, we can understand what is the relation between nodes and this topic based on the value. And after that, we are going to understand if these kind of values tend to, for example, inertia. Do you know?
Target variable in your database. I mean, can you confirm, is that true? Those topics are the target variable in your database, correct?
Extract keywords,
okay.
Exactly.
Okay, and how about the initial? Where do you find the data of initial?
So we work with different hospitals. So as I told you, it's from 10 years database. So we have around 33,000 visits, and around 6,000 patients have record in our database. You're welcome.
Okay. Has there been any application of graph theory in these topics? Because you can, with that giant cluster you've shown, I know sometimes embeddings are not always perfect at grouping them together. Has there been any application of graphs? Because if there's relationships between these 2 diseases, it would be modeled, it seems to be modeled better as a graph.
Well, we talked already about it. For example, NetworkX is one of the library that we can use to find a graph between different keywords. But you know, birth topic is more relevant because, as you see, it not only shows the topics and the cluster, but also it has also another step of the next cluster. So you see, for example, here the green one is one cluster and the blue one is another cluster. So the reason that why we use the birth topic is that it shows us the bigger view and a helicopter view of our topics, you know. But the graph can be usable in this case as we checked in the lecture review, we decided to use bird topic for these clinical ones.
Gotcha. And I guess in this downstream, you could kind of use this as an embedding model for medical terms as well. So that way, if there's, yeah, thank you.
Yeah, very quickly. I have seen recently that there is a move towards SLM rather than LLMs. Healthcare being very specific industry, have you seen in your experience is a starting point being a small language model and fine-tuned and then used, or it's still an LLMs in the healthcare industry where you're working? I'm asking this question because data set might be, like in US, there are very strong regulations on how you protect data, and you may not have good enough data in LLMs. You may need specific data in certain geography, and disease may be geography specific. So what do you see where the industry is moving, and based on your research, what's your experience?
Exactly, good questions. Well, we are working on that right now. So we use this as a, like, if we can use actually, because every step we do this kind of research, it has the privacy, you know, the EPIC and clinical notes, and every database in healthcare really has a great privacy. So we think about it, but about the output, we are not accurate about the model. If it's currently use like a small amount of data and then check it if it works or not. But we are working on that recently, and if we have any kind of this solution, I can give you the like insights offline.
Thank you.
Okay. Yeah, so there's a problem actually. So if you do smaller models, you're restricted to the data that you're using in that model. If you do larger data models, they might not be accurate, but you're utilizing a larger pool of data. So it's, I mean, I don't know what the answer is, but you have both sides have problems, right? And I mean, you're doing more research in it, so you have a better answer, right? So, yeah. Correlation part is a problem. So you mentioned about privacy. So I'm guessing you're just using de-identified data as much as possible for these experiments, right?
Exactly. So we use the clinical notes from the hospital, so we can just release the output. So we couldn't create GitHub, we couldn't share database, and we signed like this declaration that we couldn't, yes, share this kind of database.
I think a good addition to this research can be a genetic engineering of the, right? So not just the nodes, now you can have some comparison about actual genetic information of the patient and see what disease was actually relevant, right? So there's some suggestions made, but what is the actual answer, right? And then, yeah, that can be a next step probably, so.
Exactly, because the model is already built. So for example, as he said, we can add social determinant of health database, and even we can add the genetic. We already talked with our group to, if we can also add this kind of factor to our model, it's a good idea, because if we have more database, we have the better model. So we are collecting the more data in genetic, and we talk with this department. So let's see how we can pursue this.
Yeah, that has its own privacy issues and concerns. There's an open source project called Forome, F-O-R-O-M-E, which is led by Harvard University. You might want to look into it. I work with the professor very closely, Misha Bourgeonnier. So yeah,
if you can
maybe we can
that would be perfect.
connect offline. Yeah.
Thank you.
Thank you for the presentation. I have a question about slide 20. So my understanding is the backbone of BERT topic is a sentence transformer model, and I'm curious, what's the token limit of the inputs? Is it 512? And if that's the case, I mean, there's a slide you showed that your clinical notes are around 100 words or 150 words. So, but in practice, clinical notes can be much, much longer, and they can have like a lot of duplicated information. So I guess, is this a limitation of the current approach? So because once you feed a long note to a BERT model, you have to truncate it if, let's say, the context limit window is 512 tokens. Yeah, that's the first part.
Okay, good questions. Well, in our research, first I did a huge pre-processing. So with pre-processing, we can decrease the amount of clinical notes that we have. And the main reason that we choose BERT topic is summarization, the clinical. So first, it summarized all the clinical notes, and then it chose the 1 or 2 syllables keywords, and then it grouped all of them for the cluster, you know. So it's vitally summarize and, you know, generate the keywords and extract these keywords actually from the clinical notes. So that's why it decreased the...
Okay. So have you tried, so after rise of GPT models, generative pre-trained models, they're pretty good to replace many of the workflows that use classification models or clustering models, like extractions of some key elements or extraction of topics from an unstructured node. Just for the comparison, have you tried using models, generative models like GPT 3.5 onwards for the same task?
Well, we use BioBERT. So it's the only approach that we used already for our clinical nodes. But yes, we are thinking about generative AI like Llama 2 to know if it works or not, but it's a next step that we are working on that. And we think that it would be, you know, applicable in an approach. So I think it is a good idea even when we think about that, and we are going to do that, yes.
Yeah, I agree. Just a feedback that I think models like BERT or BioBERT or BERT topic, they're great for creating embeddings and doing downstream tasks like classification. But in terms of generating, I think generative AI like GPT kind of models, generative pre-trained transformer models, can outperform any existing workflows. So I think it's really good to try that. And if you can't use like APIs like OpenAI, as you said, Llama 2 is good, but I think Meta is working on Llama 3, which must be better. But in terms of open source models, I suggest trying Mistral. It's better than Llama 2.
We couldn't use OpenAI.
Yeah.
It's one of the
I work for a hospital too. We use Azure OpenAI. So there was a question in the audience, like how do you send sensitive data? If your company has a BA contract with Azure, the same OpenAI is replicated on Azure. You know, we are in Microsoft building, so I don't want to advertise. But Azure OpenAI is HIPAA compliant, and you can send PHI data to Azure OpenAI, and there is only 30 days abuse monitoring retention policy that you can remove that too, so your data is safe. Just a side note.
Yes, it's one of the good reasons we can use the Azure.
Thank you.
Is there any other question?
Question to the last person. Are you a Microsoft representative here? But on the topic of open source models, I have been playing around with the Open Hermes, which is a fine-tuned version of the Minstrel model, and just using it for general summarization, code generation, it's surprisingly well. And you don't even need the biggest one. It could run off of an old 2070, off of a gaming class GPU, and that GPU only had 8 gigs of VRAM. So if it was a concern that you need like the A100s, you don't necessarily need it. It's the best, but you can get around with some of the gaming GPUs with those smaller parameter models.
Thank you.
Thank you.
Any other question?